This is that new pump, that high power pump, supposedly. Looks identical, except for the cord's different. And I'm going to take the 4 screws out. I believe this one's been silted up as well. It failed. It's probably silted up again. And I've had kind of an epiphany. I think what I have to do is have these so... I'm going to have to use the softer tubing I bought. And have this pump so it's this way. So the shaft and the impeller are at the bottom. That way grit, I think, will be less likely to work its way up there. Because now it just follows gravity in there, you know, the little bit of grit's including in the water. Get right into that rotating rotor. This is the filter I had on it, kind of the last filter, but I think it kind of did that and let dirt in anyways. It wasn't plugged up at all. They make it a little longer with the red tubing and softer so I can bend it, you know, like that, basically. So, got this tubing, mail order, silicone, should last forever. And I got this switch. This is my switch that's going to shut it off. This pump came so that it was normally closed when the float was dangling like it is right now, and then it would open when it was up. And I want it the other way around because it's going to be submerged most of the time. So I want it up most of the time and pump running, and only to shut the pump off when there's not enough water in the jug anymore in the barrel. So the top float I'm not using, and the colors are kind of weird, and this took me a minute to figure it out. But the black pair is the bottom, and the red pair is the top. And there's like a reed switch in here. I'm figuring, you know, the reed switch inside the shaft here, then a magnet inside the float, and I just had to reverse the direction of the float, reversing the magnet to make it from normally open to normally closed, to make it work the way I want it to work. And being just a reed switch, I don't want to put the full current of the pump through it. That's why I'm going to have a transistor lighten load a little bit. And I'm just going to use a transistor for like a factor of 20 reduction of current, because I can get at least that much gain out of just about any transistor I want to use. This is when I was going to use a 12 volt pump. Then I could just switch the ground lead on the 7812, LM7812, switch the ground lead on and off to control it. And that would be one way to do it. With the pump I'm using now that can take the voltage, I'm just going to use a transistor and a resistor. And I calculated the resistor down to 240 ohms. And just like the worst case situation with the least gain possible, pretty much. So pretty simple. These aren't too bad. This is what, $12 roughly, I think. So yeah, I could switch the negative line instead and use an NPN transistor, and I may do that. I'll have to see what I dig up. Probably use like a power tab or something physically big enough to handle that fairly robust input current I'm going to have going through it. And I calculated that way just so I can assure I fully turn this transistor on. So I use like 240 ohms. That should be fine. I should calculate that current. So if I go by 12 volts and 240 ohms, that'd give me 50 milliamps. And full sunlight with this panel, I'll get actually 18 volts. So a little more current than that, but still it's well within the range of a decent little power tab transistor for base emitter current. And also it should be a good current range for the reed switches and the float switch. You don't want to put too little through switches like that, or they can get weird too. Get right in the groove. Don't want to do it too heavy. If I put the full motor current through it, it would probably not last very long. Hence the transistor. So at 18 volts divided by the 240, that gets me 75 milliamps. And that's getting kind of up there. I'm sure it's fine for the switch. And most transistors in the power tab should be able to take that, I hope. So I got a little longer piece. It'll sit in the bucket like that, so the impeller's downwards. Hopefully the silt won't work its way up into the rotor. This hose is neat. It really bends. Silicone. So the pump is silted up. You can see there's silt in there right off the bat. Different kind of impeller than the other ones had. And yeah, it's stuck in there. Wow, it's stuck in there good. So I'll wiggle that out real gently and tug it out real gently and then rinse it all out. Here I've bailed out some of the water, the cup here down to the sand level pretty much. My float switch is a little too long for the level of sand I have in there right now. So I'm going to put this in around where the sensor will land. I could have bought this one, or I could have bought one 5 centimeters shorter, which is almost too short. So I put that little container in there, keep the rocks away from that one little spot. Dug out most of the sand. It still has a sandy bottom, and it doesn't go all the way below the shirt either, but it sits there just to keep the float from obstruction. And it looks like it's going to work. I could have bought this, like I said, 5 centimeters shorter, almost too short. I didn't need the second float. I couldn't find a single float model in this length though. I gotta get this together before some light gets on the panel and runs the pump dry here. In fact, I'll cover the panel up. Okay, and there it is working, at least at this point. Pump has been taken apart and degridified. Put the pump back in a little off the bottom this time, not on the bottom, and also oriented so that the impeller's down. Hopefully less grit gets in around the rotor. We'll see how that turns out. But I think that's a good plan for now. So the only thing I have to do now is install that transistor I've been talking about. I got all those wires pulled together, and I just got to put a transistor in so the float switch will interrupt. Excuse the lighting. Anyways, I was looking through my parts bins. I didn't find a 240. I found a 390, which is probably close enough. I'll need a gain of more closer to like 40 instead of 20, so, but that should be easy. Then I found a transistor power tab all by itself, no complement nearby, so it's a 703, MJE 703. Turns out to be a pretty good transistor, almost a waste, but like I said, it's a lone wolf. I'm just going to use it. So on the spec sheet, it's got tons of gain. I can probably even go higher than that 390. I could probably use something above 1K even. Find some off value between 1 and 2K maybe. Because it's a low noise transistor, I believe. It doesn't say it is. But 750 minimum HFE. This must be a Darlington. Duh. That could be an issue. Alright, I'm going to ohm this thing out. Otherwise it would work. It's got 4 amps for maximum. 40 watts. That would be with a heatsink though. And I'm going to try to run this without a heatsink. Probably only good for about 4 watts. But that'll work. The thing I got to look at is whether it's a Darlington or not and how it's going to impact the circuit. It would probably just turn on slower voltage-wise, which might be a good thing. Maybe a certain amount of voltage before it turns on. Even more so. Yeah, it should be fine actually. I should probably go way up on the resistor though. Something above 1K. Alright. But like I said, I don't want to go too small on the resistor. I want some current flowing through that junction, so through those contacts. So I'm not going to go too much smaller. We'll see. So the Darlington's not going to work for me. I'd have to use a much smaller resistor, much higher resistor, higher ohm resistor. and not have much contact current at all going, which at some point might be unreliable on the other way. You don't want, the less current the better, you'd think, to a point, but at some point it gets so small that you're going to build the backsides with this DC voltage. So I'm going to stick with that 390 ohm. I'm going to use this, it's actually an MJE 3055, and it gets about 40 gain, which is the low end of what I can use, really. But it should work. And it's a circuit for an NPN there. Turned around, you know, that's the positive rail, negative rail. Interrupting the negative rail instead of the positive rail. So in practice, this resistor is just going to go at the end of that one black wire that comes off the switch. And the resistor will be hidden right in the wire, and the wire will just be right where I bond the other two pieces together. So that'll be like a junction of 3 there. And then the other black wire right to the base of the transistor, and then the 2 power leads. So it's going to just go point to point. Let it sit in the dirt. I was just about to button it all up, but I wanted to give the float sensor a test. So hook the ohm meter up to it and let the unit drain the crock dry, you know, run it dry basically. Which didn't take very long. And unfortunately my float switch did not open up. So something's obstructing it, and I gotta go in there again before I button it up, make sure that thing can move freely. I should have bought the shorter switch, the 250 millimeter instead of the 300 millimeter. It seemed a little too short though. Almost ready for final tuck-in. I just got to see it run one more time. This time I've checked the pump, the float switch. I got that working. I ran it till the float switch turned off. So it actually does happen. So that's all set. I installed the transistor. A little bit of heat shrink on most of the leads. Missed one lead though. It's all wrapped up in that pink foam where I had the connections wrapped up before. And that's that. I just got to see it run in the morning. Should run trouble-free, I hope. Picked the transistor with the most gain of the 2 junk transistors I had. They're old, real old junkers, corrosion on them and everything else. So perfect for this project, even though they're vastly overrated. NPN 3055 transistor I ended up using. So, and I use that alternate circuit, of course.